Yes. Dear learner, today we will discuss Kirchhoff's rules. Okay, and after going through this lesson, you will be able to state Kirchhoff's rules. You can justify these rules on the basis of basic conservation laws. You can apply these rules for circuit analysis. So, dear children, let us start with the previous discussion, that is Ohm's law, and the mathematical form. This is V equal to Ri. V equal to Ri, that is potential difference across any resistance R bearing a current I will be given by V equal to Ri. This is the potential difference. What do you mean by potential difference? That is the difference of potential at this point. Let this point is A and this point is B, so that the potential is VB. So if current is flowing from left to right, then we can conclude that VA is greater than VB. VA is greater than VB, and VA minus VB, this is equal to Ri. This is the potential difference between A and B. Here you see that there is suppose there is potential 8 volt. Potential V equal to VA is equal to 8 volt. Okay, and R is equal to, suppose R equal to 2 ohm, and current is here 1 ampere. Then what is the change in potential? There will be fall in potential by how much? R into I, that is 2 volt. So we can write what will be the potential of a VB, that will be equal to 8 minus 2, that equal to 6 volt. All these things, this type of calculations, we can do very easily with the help of Ohm's law. Right. Now let me take a simple example like this. You see, let this is one cell, a resistance, and here is another cell with a resistance, and here another resistance, and then let us name it A, this is B, this one is C. You see, if resistances are known to us, therefore this is 4 ohm, this is 5 ohm, and this is what 2 ohm. This cell is of 2 volt, this is of 3 volt. We can find easily what will be the current in the circuit. Okay, by using Ohm's law. Very simple. You see, all these things are in series, then positive is connected to positive, the effective will be equal to only 1 volt. So current will be equal to how much? Current will be equal to 1 volt divided by but 4, 5, 9 to 11, 1 by 11 ampere. Now see, this is a very simple circuit. Now suppose this is connected to certain external circuit. This is also connected to certain external circuit. This is also connected to another circuit. Now we cannot apply this one. Whatever we applied for Ohm's law, this circuit becomes complex. Any equation we want to write regarding this circuit, we have to use another law, what we call Kirchhoff's law. Kirchhoff suggested two laws. We have to take help of Kirchhoff's law here. So I hope you could understand what is the need of Kirchhoff's rules to solve, to analyze complex circuits. This may be part of a very complex For example, this circuit is part of a very complex circuit. Like I hope you have seen PCBs of pointed circuit boards of a computer, television, radio. The circuit is much complex, and a part of circuit is taken here. Okay. So such problems can be solved by using Kirchhoff's rules. Kirchhoff suggested two rules. And two rules. First, first rule. First rule is also known as current law or current rule. This is also called junction rule. Second one is the second rule. Second rule is known as voltage rule. Voltage rule, and this is known as loop rule. Loop rule. This is sorry, loop rule. Now see why it is current law, because this deals with electric current flowing through a circuit. This deals with voltage drop or voltage right. This first law is applicable at a junction, therefore it is junction rule. It is applicable for a loop, closed circuit, therefore it is loop rule. Okay, so we must see very specifically what are junction and a loop, and in between we will discuss branch. These three things we will discuss first. Before we state Kirchhoff's rule, we must know all these things. You see, we come to this simple circuit, or let me take another circuit. And suppose this is a circuit I am taking like this. Okay, this is R. This resistance is R1. This resistance is R2. EMF is E1. That is E2. E1 and E2. Okay. Now, what are junctions? And suppose this is also a part of some extended circuit like this. Okay, extended circuit. Now, what is a junction? You see, this is the point. This is the point A. Here you see three lines are being connected: one, two, and three. Okay, this point A is a junction. A is a junction. Again, you see this is another point where again three lines are connected. B. This is suppose the direction of current. Okay, junction. But this point C, we will not call it a junction. Okay. Right. Then what a junction is? Junction. Junction. It is the meeting point of more than two lines or two paths of electric current. This is junction. Okay. And what is A branch. So here we can see that A is a junction, B is a junction, C is not a junction, D is not a junction, but you see here, as it is B, C, D, and suppose this is E and F. E is one junction, F is also a junction, but C is not a junction. This is a turning only. Any point which is connected with or which is the meeting point of two lines only, this we will not call a junction. So junction is one where at least three are being connected. So you see, let me erase this one. Okay, then this is junction. Now let me come to branch. Branch, the path, the direct path of current from one junction to one junction to another. That is in this, in the previous figure you see, in the this, if we consider this figure only, then A to B is a junction, so is a branch. A to B is a branch. B D C A is one branch, but A E F is not a branch. A E F is not a branch because this is not direct path. We are coming across one more junction, from one junction to another junction. This is what a branch. So what is the specialty of a branch? In a branch, current current through each element or each component, we can say each element is same. Current through each element will be same. That is if A, this is point A, and this is a junction. Sorry, A is junction, and we are reaching to B, and there is another branch. And C. If we consider A, B, or between A, B, this branch, B, C, D, A, this branch, then you must remember that current through this resistance R1, current through this resistance R2, and current through this resistance R3 will be same. All current will be same. If here is current 1 ampere, here also current 1 ampere. Okay. This is a branch. Now loop. Another one is loop. What a loop is? A closed circuit, a closed path of current, path of current is a loop. Okay. Closed path of current is called a loop. Here you can see A, B, C, D, A is a closed path. We can see this side also A, E, F, B, A is a closed path. Okay. Now let us start one by one. Kirchhoff's first law. Kirchhoff's first law. Kirchhoff's first law. This law states that this is already, I told you that this is, deals with current. This is applicable at any point, at any junction. Okay. So what this law states that in a network of conductors, the sum of current meeting at a junction is zero. Sum of current meeting at a junction is zero. This is Kirchhoff's first law. Mathematically, what we can write summation of I is equal to zero. If we consider a junction in this here I equal to zero, zero. If we consider a junction with five conductors like this, suppose this is I1, this one is I2, this one is I3, this one is I4, this one is I5. Sum of all current is equal to zero. How is it possible? Only when some currents are positive and other currents are negative, then sum will be equal to zero. So which currents will be taken as positive, which will be negative? Very simple to understand. Current meeting the point or incoming to the point P are taken as positive, and leaving the point P they are taken as negative. So according to this, at junction P, at P what we can write according to Kirchhoff's rule, first law, that is I1 is positive, here I2. Sign of I2, it is leaving the point P, so negative. And then I3, it is again leaving the point P, the body is negative. Then I4, it is also, it is meeting the or incoming to P positive. And then I5, that is minus, I5 is equal to 0. Okay, what happened? So what we got? That yes, I1 minus I2 minus I3 plus I4 I4 minus I5 is equal to 0. Here what we can write here, there are just rearranging I1 plus I4 is equal to I2 plus I3 plus I5. These currents are incoming current which are meeting the point P, I1 and I4. And this current, that is I2, they're leaving the point P, therefore they are outgoing current. So what we can write? Incoming incoming current, and this is what outgoing current. So Kirchhoff's law can be stated like this: that incoming current is equal to outgoing current. Okay. So at any junction, if you consider any junction. Now, how this law is justified, or what is the proof of this law? You see, very simple logic is there. Very simple logic. Proof of this law. The flow of current. Let us come to the definition. What is flow of current? Current means charge. Very simple. Charge. If you want to find what is the current flowing through this conductor, means what you have to do. You have to sit somewhere at any cross section. You have to sit, and what you have to do. You have to count the charges passing this cross section in 1 second. This is the current. And suppose there is a junction. There is a junction. This is a junction. If you sit here, then what you have to do? How many charges, or what is the amount of charge that is passing this junction? Passing the junction means leave incoming to the junction and leaving the junction. Okay. Then passing means incoming as well as leaving. Incoming as well as leaving. If any difference occurs between incoming current and outgoing current or leaving current, if any difference occurs, it means some charges we are going to add here or some charges we are going to destroy here, and which is not possible according to the law of conservation of charges. Therefore, incoming current is always equal to current leaving the point. Incoming to the junction equal to current leaving the junction. This is what this is a this simple law is taken as what Kirchhoff's first rule. Now, a very simple example. Let us solve an example. See, this current equal to 1 ampere. This current equal to 0.15 ampere. So, what is this current? Or this current is equal to I. This current is equal to I. Again, current is equal to, this is equal to 0.5 ampere, and this is the final current, suppose I2, and this is suppose I1. So can we find I1 and I2? Very simple. I1 for this point P, let this point is Q. At P, what we can write? At P, what we can write? 1 minus 0.15 minus I1 is equal to 0. This is summation of I is equal to 0. And therefore, I1 can be written as 0.85 ampere. Here you see, at the point Q, if we want to apply Kirchhoff's first rule at Q, what we can write? This is 0.85 to incoming current. So this is positive, plus 0.5 is also incoming current, this is positive, again minus I2, this is negative, is equal to 0, and therefore I2 will be equal to 1.35 ampere. This is how we can apply Kirchhoff's first law. Okay, now let me erase all these things. Okay, so uh, we could understand what is Newton's first law. Now we'll discuss, Newton's, not Newton, Kirchhoff's first law. Now let us discuss Kirchhoff's second law. Kirchhoff's second law we'll discuss. Kirchhoff's second law. Second law is also known as loop rule. Loop rule or voltage rule. Okay. Now this is applicable for a loop. This is applicable for a loop. second law or loop rule. So what is according to this loop that the sum of potential changes in a closed loop in a closed circuit, closed path of current is 0. Then summation of V is equal to 0. Loop, let me consider a loop. Let me consider a loop in this. See, um, first one circuit. This is a cell E1 and R1. This is a resistance. Okay, this is another cell. So this is E2 and R2. Right. Loop. Loop means closed path. So you can see how many closed paths are there. There are three closed paths we can consider. That is A, B, A, B, then C, D, and E, F. Okay. This we will apply for closed path here. Closed path here. Let me consider one closed path A, B, D, C, A. Closed path. Another closed path you see C, D, E, F, C. Or other closed path you can see that A, B, D, F, E, A. Okay, like this we can consider closed path. But how to apply? What is the rule? Summation of V is equal to 0 for potential changes. Again, you see summation of V equal to 0 means some potential changes will be positive, some potential changes will be negative. Which changes are taken as positive, which changes are taken as negative. This is very important and you have to remember this and just to do practice, no problem, automatically you will understand. Positive change. Positive change means rise in potential, potential. Okay. What is rise in potential? Suppose you are okay, current is flowing like this, P to Q. You are calculating potential changes from P to Q. You are going from P to Q, then from the direction of current, simply you can conclude that Q is at higher potential. Why? Because current flows from higher to lower potential. So when you are going from P to Q, there is rise in potential. There is potential. That is, you are going from lower to higher potential rise. If there is rise in potential, you can assign a positive sign I1 R1. Okay. Really fall, or if you come across one cell, irrespective of direction of current, the cell, the electrodes will develop electrode potential and the potential difference in between them, there is the EMF of the cell. The cell itself has some potential difference and negative terminal will be at lower potential, positive terminal at higher potential. So if you are calculating from A to B, it means there is a rise in potential rise. means again plus, you will assign positive sign. Now, fall in potential or negative sign. Negative sign, what negative sign? Negative sign आप किसको assign करेंगे? To very simple that negative change. What is negative change? Negative change is what fall in potential, decrease, fall in potential, potential drop, drop of potential. Okay, very simple. Rise the direction of current. Just if we reverse, we can understand this. If the current is flowing from P to Q, if the current is flowing from P to Q, then what kind of change is there? There is Vp is greater than Vq. That is a potential fall. Potential is falling. As you are going, as you are calculating from P to Q, then there is fall in potential. In this case, if the current is I2 and this is R2, then what you can write? I2, R2. Similarly, so I already told you what is rise, rise of potential. This is what R2 and this is I2. Then there is rise in potential, and this will be sorry. This is fall in potential, fall in potential. So that we will assign here a negative sign I2 R2. Similarly, if we come across a cell like this, positive to negative means you are falling down, and again you can write negative E. Okay. So this is what rise and fall in potential. Now we have to apply all this concept uh, to solve a simple problem. Let us write equation on the basis of Kirchhoff's second rule. Let us consider a simple problem that this is a cell, this is a 4 volt, this is a 1 ohm, a resistance, okay. This simple problem will solve. This is 3 volt and 1 ampere current. Okay. And what we are going to find? We are going to find what is the value of I1. This is suppose 10 ohm. This is what is the value of what I2. Oh, sorry. If here current is I2, here current is I1. This current is I1. This current is I2. Then obviously this current using Kirchhoff's second rule, you can write first rule. We can write this current is equal to what I1 plus I2. Okay, here current is like this. Here current like this. This current has to be equal to same branch I2. Here this current will be equal to what I2. Okay, but we are going to find simple. Our target should be fixed. That is I1 equal to what I2 equal to what. That only these two things we are going to. What we will do? How we will proceed? First law we have to use. We have shown the distribution of current using first law only. Second law, using second law we will find equations, and from these equations we will solve for I1 I2. I1 and I2 are two variables that we have to set for two equations, and from two different loops, but we have three loops. We can take any two loops. Okay, let me write here, name there A B, this is what C D, this is what EF. Okay, let me consider the loop A B, for the loop A B D C. A. Okay. So A, B, D, C, A. Yes. Then let us start from A. Our direction of calculation will be A, B, D, C, A, like this. Yes, so let us start from A, and then first we will come across the EMF. EMF, you see, here we are going from negative terminal to positive terminal, means there is rise in potential. 4 voltage rise in potential means plus. Now see, across this, across this, current flows from current flows from higher to lower potential, and therefore we are going towards a lower potential, that is falling potential. Fall means I1 minus I1 into 1. Okay, fall in potential. Here you see again in the same direction current, means this point has to be in at a higher potential, this point is at a lower potential. Okay. Sorry, at a higher potential, this point is at lower potential, and then D is at lower potential, D is at higher potential, C is at lower potential. So what we can write again, we are falling down, means that will be how much, 10. What is the current here in this arm? The current is I1 plus, I should use the term branch. In this branch the current is equal to I1 plus I2, and that has to be equal to 0. Therefore, what we are getting, 4 minus 11 I1 minus 10 I2 equal to 0, or very simple, 10 I1 plus 11 I1 plus 10 I2 is equal to 4. 4. Equation number 1. So we have got very simple equation 1 I1 I2. We have to choose now another circuit. So according to your choice, we have two options. One is one is simply A, B, F, E, A. Another option will be there, E, C, D, F, E. Okay, let us consider this A, B, A, B, F, E, A. Okay, and according to this loop, you see A, we are again coming across 4 volt, that is plus 4 minus I1. Now we come to here directly. Here it is how much? This will be at higher potential, that is at lower potential. So there is rise in potential, plus I2, and we are going from this to this, in this direction, means we are going from positive terminal to negative terminal. There is fall in potential, minus 3 is equal to 0. So this comes to what? I1. What is this is what 1 ohm, sorry, 1 ohm. So this is what I1 minus I1 plus I2 will be equal to minus 1, and therefore I1 minus I2 equal to 1. Equation number 2. Now from 1 and 2, if we want to solve, we can solve it easily. Now you see, right here, that is the equation is what, I1 minus I2 is equal to 1. Equation number 2. Okay, this is what um, second equation. Now using these two equations, we will try to solve. We will try to solve for I1 and I2. Yes, we will try to solve for I1 and I2. How? You see, a first equation is 11 I1 plus 10 I2. Let me see once. First equation is 11 I1 plus 10 I2 equal to 4. this is equal to 4. And second one is I1 minus I2 is equal to 1. Okay. Now we can solve by multiplying this with 10. Okay. Then what we are getting, that 10 I1 minus 10 I2 is equal to 10. This equation, and this equation is 11. It is I1 plus 10 I2 is equal to 4. So we can solve for this. The 21 I1 will be equal to 14, and we are getting I1 is equal to 14 by 21, that is equal to 7 to the 14, that is 2 by 3 ampere. Correct. In this way, we can solve for I1, and then from this equation, for any one equation, we can solve for I2. We can solve for I2. I1 minus I2 equal to 1. So I2 will be equal to 1 minus I2 will be equal to I1 minus 1, that is equal to 2 by 3 minus 1, that is equal to minus 1 by 3 ampere. Now minus what is the, yes sir, there is one very simple explanation. You see, minus 1, I2 is minus 1 means what we have assumed here I2, what is the direction of I2, here the direction will be just reverse, minus 1 by 3. So we don't have to think during the distribution of current, just you apply correctly in, but Kirchhoff's first rule. Okay, no problem. If you are taking wrong direction of current, there is no problem, but first rule of Kirchhoff should be applied correctly, and ultimately you will get the result as positive or negative depending on the actual direction of current. Okay, so in this way, what we can do, we can solve for different circuits using Kirchhoff's second law. Now let me justify Kirchhoff's second law. How we can justify? You see, potential difference simply depends on, or we can say proof of uh, Kirchhoff's second law. Potential difference, this depends only on 2 points. We always talk about potential difference between 2 points. Okay. Now if you are taking a closed circuit, you are taking closed circuit. Now if you connect this voltmeter to the same point only, what will be the voltage? What will be the reading in the voltmeter? Is simply equal to 0. So all the potential difference between P and P will be equal to 0. Therefore, once when say round the closed circuit, net potential change will be equal to 0, because net work done to bring a unit charge from one point to the same point is always equal to 0, and therefore, or what we can write that Kirchhoff's second law is the consequence of conservation of conservation of energy. So, dear learners, you could understand what is a Kirchhoff's first law, what is second law, why are they called loop rule and junction rule and loop rule respectively, why are they called current law and voltage law respectively, how you can account for potential rise and potential fall, and one very simple conclusion you can draw, that if you are your calculation, direction of calculation matches with the direction of current in the circuit you have already pointed out, then you will take this a potential change as negative, because current goes from higher to lower potential, means you are falling down, so this is a negative. And if it is opposite, that is your direction of calculation is from P to Q, but Your um, the direction of current is q from q to p, means opposite to that, means you are rising. You are rising. Okay, that is potential is rise. Again, in case of what, in case of sales, if you are calculating from higher potential to lower potential, that is a positive terminal to negative terminal, there is obviously fall in potential. If negative to positive, then there is rise in potential. Okay, but this there may be some instances where there is a capacitor, there is a capacitor, then what will you do? No problem, same thing, same thing. Which one is higher, at a higher potential, which one is at lower potential, you can see. Okay, you see if a current, but direction of current, we give like this. Here, direction of current is like this, and then this point, this point will be at higher potential. This point is at lower potential. Okay, if we take like this, then and what happens accordingly? What we can do? Positive plate to negative plate. Positive plate means higher potential, negative potential, negative plate means lower potential. Then what you can say, that accordingly we will take the potential change. Now, so for a closed loop, just we have to do, we have to calculate the changes in potential, and we will sum them up, then equal to zero. This is Kirchhoff's second law. Okay, I hope you will be able to solve different problems using this law. Thank you very much. Thank you.